Welcome to CS 1401 Video 16.1. I'm going to discuss a way to bundle different pieces of information together into objects, which are defined by classes. When I presented arrays, I talked about the problem of trying to manage a large number of pieces of information. The problem was that if we had to have a different variable for each piece of information, then we'd have to define large numbers of variables and pass them individually as parameters to methods. If we didn't have arrays, imagine trying to call a method that took as an argument all the grade point averages of the students in UTEP's computer science department at the end of the semester. The method would have to have hundreds of arguments. Arrays solve this problem because we can refer to the whole collection of grades with one variable that refers to an array of floating point numbers. In an array, though, the data are all of the same type. Every item in the array of grade point averages is a floating point number representing a student's GPA. Okay, so far so good. But what if we need to have a collection of pieces of data that were of different types? For example, suppose for our CS 1401 class, we want to compute the course grade for each student. To complete this task, we would want to store 6 pieces of information for each student: the name of each student, his or her email address, UTEP ID, attendance information, quiz scores, and exam grades. But arrays have data that are all of the same type. We'll need another kind of structure that can avoid having to pass 6 variables for the 6 different pieces of information. To solve this problem, we can define a custom data structure, a class, called student, that will have all the values for each student in it. Anytime we have a new student, we create an instance of this student class. This instance is called an object that comes with that predefined set of variables. In other words, the student class is a sort of blueprint from which we can build many instances of student objects. Many programming languages enable programmers to define classes and to instantiate objects from a class. This lets us use objects to represent real-life entities and concepts. Classes can also define behaviors, which in Java are called methods, and in this course we already know how to define methods in Java. So to create objects, we need the blueprint, the definition of the class, which specifies the data and the behaviors associated with instances of the class. A class's behaviors often describe how its data fields can be used or accessed. Using a class, we can generate as many instances of an object as we need, and all of the instances will have the same set of behaviors and fields, even though the data in these fields will probably differ. Let's look at some examples of classes, starting with a class for student. Abstractly, at a pseudocode level, we'll want our class to be named student with 6 data fields. There'll be a string that contains the name, a string that will contain the student's email address, an integer for the student's ID number, an integer for the class attendance, an array of floats for quiz scores, and an array of floats for midterm scores. Now, from that pseudocode, I can start to define the class student in Java. Here's my Java code. I'll define public class student with string name, string email, int ID, int attendance, float as an array, quiz, which will be a new array of length 16 of floats, and an array of floats called midterm, which will be a new array of floats of length 3. This class has variables that can be used to store the student's name, email, ID, attendance, quiz, and midterm grades. Classes can also have their own methods, and I'll get to that in a little bit. A class can be created for just about any real-life entity, event, or concept. For example, if we want to keep track of the books we've read, we can create a book class. Each time we read a book, we will create an object of this class with all of its information. Here's a Java definition for the class book. The class will be public class book and will have the following fields: a string called title, a string called author, an int called year published, a float called price, a string called rComment, in which I can write my own comments about the book, and a Boolean called liked it. Or we can create a class to store information for soccer players. This would be public class soccer player, and the fields would be string called name, an int with the player's jersey number, a string with the player's team name, a string with the player's position, and an int for the number of goals that player has scored. These variables, name, jersey number, and so forth, are called instance variables because each instance of the class has its own values for these variables. So one instance of soccer player could have the name Ronaldo with jersey number 9, team FC Barcelona, etc. And another instance of soccer player could have the name Mia Hamm with jersey number 9, by coincidence, team US Olympics 1996, etc. I mentioned a moment ago that a class can define behaviors for objects based on that class. In Java, we can define methods for classes. One kind of method that's especially useful is a method that initializes the variables of each instance of the class when it's created. Every class can have a method that initializes the instance variables of objects of that class with default values. This method, known as a constructor, generally has the same name as the class. For example, a constructor for the student class could be public student, and the name will be equal to no name stored yet as a default value, missing email address as the default value, the ID number will default to 0, and attendance will default to 0. This particular constructor method does not have any parameters, but you can write constructors with parameters that have values that can initialize variables. Also, notice the constructor does not have a return type. This is how constructors work in Java. These methods are special types of methods, and they do not have any return type, not even void. As I said, the class is the blueprint. To create an actual instance, called an object, let's create a class called grading. Grading will have a main method, and that's where we'll create an object of the class student. To create an instance of a class, or an object, we need to specify the class name, which will be student, followed by the name of the object, which should be a valid variable name. As I've said, classes provide a blueprint that can be used to create instances of the class. These instances are known as objects, and object creation has three parts. One, a declaration. Similar to variable declaration, we create a name for the object and link it to a particular class. Two, an instantiation. The new keyword is a Java operator that creates the object. And three, initialization. The new operator is followed by a call to a constructor which initializes the new object. The new operator returns a reference of the object it created using the constructor. So when I create an instance of class student, I'll need a declaration, an instantiation, and an initialization. Let's look at an example. Student S1 equals new student, where S1 is the name of the object that we're creating. This object is of type student, and the constructor student with no arguments assigns default values to the variables of this object named S1. Now, let's print the name and email address of S1. It shows no name stored yet and missing email address. Notice that object creation is similar to variable declaration. For example, int count equals 10. That is, at first you specify the data type, int, then the variable name, count. Similarly, for objects, you declare the data type student followed by the variable name S1. After you declare the variable, you can initialize it. For example, count equals 10. In the case of S1, you initialize the variable with the constructor using the statement S1 equals new student with no arguments. The constructor method we wrote has no parameters, so we don't pass any arguments when we call this method. Within the constructor method, we initialize the variables such that the default values of the variables are either some string or 0. A class can have multiple constructors. We can create constructors that take one or more arguments. We can then use the arguments to initialize the variables. Keep in mind that even though there can be multiple constructors, each one of them should have a unique signature, which means the sets of parameters and the types of those parameters must be unique. Let's look at some examples of different constructors for the class student and how they can be used to initialize an object. This particular constructor takes student name as a parameter and assigns that student name to the name variable. Here's another constructor which takes two arguments of type string, the name of the student and the student's email address. These arguments are used to initialize the name and email fields for the object. Here's another example. This constructor also has two parameters, but one is of type string, which is the student name, and the other is of type integer, which is the student ID. When we create an object using this constructor, the name variable we assigned the value of the student name, and the student ID variable will have the variable of ID. Every object of a class has the same fields and methods. There are different ways to access these fields and methods. Suppose a method of an object needs to access the fields or other methods of the same object, that is, the object itself. In that case, using the name of the field or the method will be enough. For example, to access the value in the field attendance, we can just write attendance. But what if we are trying to access these fields or methods from another object? For example, let's say we are inside the main method and we created two student objects called Anna Minor and Beto Minor. How do we view Anna Minor's quizzes and Beto Minor's quizzes? In such cases, when we want to access the fields of an object, we write the name of the object followed by a period, followed by the field or variable name. For example, Anna Minor dot quiz sub 0 will provide a direct access to the first quiz grade of Anna Minor, and Beto Minor dot quiz sub 0 will provide the grade of Beto Minor. Let's create an instance of student with the name Anna Minor. I could do this either by using a constructor with no arguments and then setting the name field. So S1 equals new student, and then S1.name equals Anna Minor. Or I could use a constructor that sets the name. S1 equals new student Anna Minor. If I then print the name and email the student, we will see Anna Minor and that the email address is missing. I can then set the value of the field email address using the same approach. S1.email equals, quote, aminor@minors.utep.edu, close quote. Now when the program prints out the values of the object's fields for both name and email, I get values for both. Well, That's a look at classes, objects, how to create objects with constructors, and how to store values in instance variables. In video 16.2, I'll discuss how to define other sorts of methods for classes and their objects. See you shortly.